Hello, everyone. Thank you for coming. Thank you to the MySQL community, Oracle, for putting this together. I think it's been great so far, and hopefully we continue it. My name is Alexander Martinez. I'm from Yelp. I'm a software engineer on the DRE SQL team, and today I'll be talking about our MySQL 8 upgrade from 5.7, or as we titled, a 5-star upgrade, users, reviews, businesses in MySQL 8. So just giving an overview kind of the topics we'll cover. I'm going to give a brief introduction to myself, the info at Yelp, why we would upgrade to 8.0, some of the dependencies and steps we had to lay the ground for the migration and the actual migration process for us, the challenges and solutions we came up with to get this all done, and then kind of the future that's been MySQL 8 and will be hopefully as time progresses. So yeah, I started Yelp, I guess right before the pandemic, October 2019. And then I actually joined the SQL team, DRE SQL, in May 2020, and been working on there since. Initially, I led the project for our upgrade, a lot of the dependency work, and then since then, I guess most recently, I'm leading the modernization of our MySQL ORMs, which we'll talk a little bit somehow in this path forwards, to SQL Alchemy, which is the majority of our ORMs at Yelp already. So to give a little introduction of MySQL data at Yelp. First off, we've been running 5.7 at Yelp since 2017, I believe is when they completed the upgrade from 5.6. We store a lot what we call Yelp's data golden triangle in our MySQL DBs. So user data, reviews, businesses, a lot of the core stuff that goes into Yelp's product and websites and applications. And then additionally, we provide that MySQL data to analytics databases, streaming applications for use cases like ads, billing, and then real-time applications, so some of the things within the Yelp app itself, like geo stuff. And then kind of give an overview before I dig into the actual upgrade and some of the dependencies. At Yelp, we use Ghost for our schema changes. And then we use Orchestrator for not only our primary failovers, intermediate master failovers, but also for managing our replication topology hierarchy for MySQL clusters. Our replication hierarchy at Yelp is a single primary for writes, intermediate master, and then replicas for various use cases, including reads, reporting, and sourcing our change data capture infrastructure. And then we automate our backups written on top of Percona Extra Backup to perform backups. And reason why I'm introducing all these kind of not only to give landscape of what we do at Yelp, but also I'm going to provide some more details for it later on as to how they fit in and help us either solve or address certain issues. All right, so MySQL 8's been out for quite a few years now. I know end of life has already passed at this point, but when we were planning this back before 2020, the main reasons why we kind of considered this were, one, modernization. There was the UTF-8 MB4 character set change, which allows for us emoji storage in a lot of our databases. New features including column data type, so JSON optimization, invisible indexes, which is great for a lot of our feature engineers and users, so that we could swap an index in place without having to run a whole Ghost schema change, especially on the larger tables at Yelp. It could run multiple hours, if not multiple days. And then dual passwords, which allows easier password rotation, allowing us to automate our security side of that a little bit more. And then finally, end of life for 5.7 was approaching, and so we wanted to improve our security posture as well by upgrading to 8.0. So before we could actually migrate either development or production ecosystems, we initially we actually patch our libraries, the MySQL fork internally, and so we had to test a lot of the libraries with that, roll it out to our clients or applications, and then we wanted to verify the read queries in both development and production, and then eventually I'll dig into the actual process of upgrading all of our servers at Yelp. So yeah, as I mentioned briefly, we patch a local MySQL fork in the community version at Yelp to allow it to work with our Yelp, ecosystem or engineering. And additionally, we run MySQL client libraries, including client, connector, and server. and these would have to be ported into our patch as well too. Since 8.0 was usable with 5.7, we were able to roll it out forward with over 250 MySQL client services and upgrade that before actually upgrading any of the MySQL servers that we run in our infrastructure. And that's actually what led to a lot of, I would say, some of the time leading up to this, so setting that ground, that upgrading all the individual client services themselves. Once that was completed, this is actually one of the bigger issues that we ran into. So before we started our upgrade to 8.0, originally at Yelp, we sourced all of our change data capture data through what you can see here as a refresh replica within our primary cluster. That refresh had a writable ability because that was needed for the sourcing. And yeah, as mentioned, originally it was within our replication hierarchy in the actual primary cluster. The only issue with this is it only supported 5.7 at the highest, and there weren't any plans to support 8.0 or change that until at least 2023, and I believe it was Q4. I'll show the next slide. We were using Vitess to sanitize production data into our development ecosystem. And so similar with using that same B replication, we could materialize the same table data into a separate physical cluster, which you can see on the right here is what after. We take the bin log data through Vitess, and then we can rip out our own, or partition out its own separate refresh sourcing cluster. So that way we could deal with all the traffic-based stuff, anything with batches on the servers, upgrade all that to 8.0, and then whenever CDC stuff was prepared, we could swap it over or just delete it depending on the future of that. And so this planning was before 2020. And yeah, as I said, the 8.0 or replacement for the CDC infra wasn't planned for at least 2023. And this kind of gives an overview. Again, we were planning, I think it was Q3 2020 at the latest. We were finalizing things, especially for how we were going to isolate this. And we were able to save ourselves almost a couple of years at least. And unfortunately, that Q1 2023 was quite a bit extended too. So we probably saved ourselves a few more years than just a couple of years there. And then, as I mentioned before, actually upgrading any of our development or production servers, we want actual confidence before switching over the traffic and spinning up those servers. So as kind of seen here, we have an example of a Yelp app, someone looking up restaurant data. And what we did was we spun up a 8.0 read replica, and since we use proxy SQL to route a lot of our all of our traffic, we were able to use mirroring a feature which allows you to route select queries to a separate host group. So that way we could have our live traffic in the main host group that keeps serving read replica stuff. And then the 8.0 could mirror some of the select traffic. So therefore, we could see how the query performed from the application side. Was there slowness? Was there any errors that we didn't see previously before we actually spun up and started adding some of the application traffic to those 8.0 servers? So now that I've set a lot of the foreground that we had to build up before we could actually get into it. Was the main, once that CDC isolation was done, we moved on to actually upgrading our environments. So initially we had development, which is obviously kind of like a staging option for us before we get to production. The first few steps do apply to both ecosystems, and later on I'll kind of discuss the separation of production, some of the specialty things that we rolled out. But initially we had an in-place upgrade, so we upgraded a 5.7 server in place to 8.0. Began reading traffic to that. We had to wait at least 70 or up to 72 hours. So we have automation to take our backups with Bracona Extra Backup. We'd make sure that the 8.0 replica took its backup as expected. We would verify the backup works. And then at that point, we would proceed with rotating either manually, or we also have automation for decommissioning replicas to swap over to 8.0. So each time we bootstrapped a new replica, it would then pull up 8.0 instead, and then we'd terminate or decommission the 5.7s. So the last step, and you kind of see this has been iterating through, is switching over the primary failover. In dev, that was pretty simple. We just did a primary failover with orchestrator, and then decommissioned the 5.7 former replica or primary once we were complete with that. With production, we had a little bit more of an issue, especially with our first production cluster. We didn't want to just roll it out and then tell our feature teams or developers, all right, we're on 8.0, good luck. If anything broke, you're on your own, or we'll figure it out after the fact. So we kind of, since we can't replicate 5.7 from 8.0 servers, we got creative. As we mentioned before, we use Vitess now a few different use cases, and we realized that we could tear out the former IAM 5.7, stop replicating from the server before the primary failover. And then if things were to have an issue, so we send out an email ahead of time saying, hey, we're going to start the primary failover now, or at this time tomorrow. We'll have an hour window for you to verify any of your queries, applications, make sure nothing broke. If anything somehow did break, we could then use Vitess to replicate the data to the former IAM that hasn't been replicating, and then go back to replication through, or writes through a 5.7. We use this for our monolith cluster, our shared tenant cluster, and which were the main concerns when we rolled this out, because those are some of the largest use cases at Yelp for MySQL DBs. Journey wasn't that easy. I know it seems pretty tied up in a neat bow. There were some lessons learned, let's just say the least. And trying to get some framework of how that happened. I know some of you have read up about 8.0, have probably seen some of the other, I think GitHub and I forget who was a Facebook or Uber have talked about the issues they've seen, whether it's TempTables and other things. Well, yeah, it hit us too. So first, TempTables. When we were first upgrading, we actually chose 8.0.2.1. So we got to production and realized there was some performance issues. Did the whole process over again for 8.0.2.4. Things were looking good. We actually got to production, so we thought we were almost done. And then after our first primary failover, we suddenly saw, or sorry, our first full upgrade, we saw 2 primary failovers within 24 hours. We don't get that primary failovers that often, unless AWS reaps one of our primaries or something truly went wrong. But yeah, I've been on the team now for at least 6 years almost, and especially 2 within like multiple, like that quickly, we knew something was wrong. So we began investigating and quickly realized that we suffered a, as you can see kind of down at the bottom, a network partition or split brain, especially once we talked to our feature teams and realized that we had data using different, or same primary key, for example, for different rows that shouldn't have existed. Like one should have taken it, but no, the new primary came over from replica that never got the data, which led us to, as you saw on the previous slide, why I talk about semi-synchronous replication. So it was kind of a larger picture. There was quite a bit of fire. And yeah, we were obviously, this was our first upgrade in production, or at least full cluster swapped over. It was past the rollback window. I think it was the next 24 hours that we realized this was becoming an issue. And what was happening was with the beginning of 8.0.2.3, TempTables, the storage for internally for writing to disk, how they represent things, was changed to TempTables. And the way we had it laid out with the default settings, we were basically just filling up our disk on that primary to the point where orchestrator no longer found it visible. And so it did its failover, nice and easy, make it simple. But unfortunately, because that server was locked up and disk was full and unreachable, that's where we started having that issue. Well, and also the replication strategy we ran at the time. So before all this, we were running asynchronous replication, primarily just to prevent any latency issues with our replicas. Only issue with that is you don't wait for any acknowledgement or data to get to your replicas. So as soon as it gets to the primary, it's committed to the application, done. However, in our case with that network partition or split brain, we suddenly had the new primary coming up and saying, oh yeah, I get to have ID 100. Well, the former primary tried to write that before it crashed. So took it, and some of the applications are already seeing with the former primary with asynchronous replication, hey, I thought you said you already took that and written it to disk. So for us, we had to first test out semi-synchronous replication. One, is this going to slow down our production databases and affect our applications? And then two, how do we roll this out to every single new 8.0 cluster? So initially, obviously, we only had one cluster in production that was running 8.0, and this was suffering the primary failure concerns. And so we tested this, I think I want to say the same week, to make sure that performance, so using Vivid Cortex and other tools, that none of our queries slowed down with switching the replication strategy once we installed and enabled the plugins on the servers, or within that cluster, so the primary and the replicas. And then once we had that tested, we actually automated the configuration enablement for all of our 8.0 servers. So the moment that we did a swap something in place to 8.0, or we did bootstrapped a new 8.0 server, or did a primary failover, we enabled we downloaded the plugin and enabled it on the servers themselves, so that it was running the moment the 8.0 was started up. And then in order to check that we had no issues with this change or pretty drastic change in our replication strategy, we checked query latency. We made sure our MySQL servers didn't see any CPU spikes or disk changes. And then also we made sure none of our clients, so like applications that actually talk to our DBs, weren't seeing any errors. So before I should get into, okay, the journey's done, what would we win from that, or what do we gain? Our second major upgrade in production, so about wrapping up, okay, we've got all development done, we're wrapping up production. We couldn't get new hosts to Bootstrap. And it was quite surprising, because in our mind, the first cluster we did in production was actually the larger one. So we're like, okay, what's the issue here? Well, the second one was a multi-tenant cluster, unfortunately. And that data, Yelp's, I think we went public, 2011? We've been around since at least 2007. Our data's grown over the years, and we don't usually get rid of it unless we clean it up. But all that stuff, like user reviews, we want some of that stuff there unless the user asks us to get rid of it or something for the length of that business and such. So with Percona 8.0, there were some configurations that we found that were actually causing this, or at least making this a bigger problem than it could have been. So in addition to our data growing and slowing down how long it actually takes to bootstrap a new replica or stream the bin logs to that new replica, we had these two configurations, which are by default set to true, and by switching them to false, we ensured that we could actually, or what it was doing was slowing replication of our bootstrapping and locking for TempTables. And so by setting these to false, we allowed a faster bootstrapping. And then additionally to this, we actually ended up sharding out some of our larger virtual clusters from that database. So that allowed it to, one, shrink the data size. So obviously it's going to gain benefits, but preventing the source of the bootstrap replica from locking up from these settings. And we already pulled that the source out of traffic, so we weren't concerned about messing up with replication or read queries. So we figured, why not make sure that it was performant as possible for the task at hand that we had chosen it to do, which was replicate the binary logs to a bootstrap new replica. All right, so that was our challenges, a lot of our things we ran into, and then how we solved them. I mean, I think we had at least 5 or 6 DRE software engineers working at all times, in addition to like feature teams and such to get this done. But yeah, what were the wins? We had user-generated content, reviews. People like to use emojis these days. And so we had a lot of teams that were wondering, when could we get emojis in MySQL? That was the first thing. Character set change, UTF-8 allowed us to begin doing that. And so we first did it on a lot of our larger tables, especially in our monolith. So even before our upgrade, we applied these character set changes to make sure that we didn't have to do it after the fact with a ghost change once we saw issues. So tables that were, I think we chose the 10 largest ones and made sure those were done in production right away, and along with all the development tables. And then The remaining ones we gave to the feature teams, depending on basically when they wanted emoji support, as long as once we verified that both character sets worked with our 8.0 servers for both reads and writes. I'll get back to JSON. We'll come there. Invisible indexes, I think, was a big win for us. As I mentioned before, we have some tables with traffic and CDC sourcing. In order to run a schema change on that cluster, it can take multiple days. To swap out an index on that table is painful. I've been the lucky candidate to have to do that multiple times, and to watch replication issues on the cluster for 2 days, make sure everything goes fine, no impact. It's a lot nicer if you can just pass in place, hey, invisible or visible index. So just drop that IN prefix instead of waiting for the whole ghost plan to apply to your table and then swap the table. Okay, JSON. That's probably the only thing we haven't gotten to yet. Mainly because performance, I think everyone knows JSON, not the best at MySQL. 8.0 was supposed to be a large improvement. But we want to make sure that we actually test and verify that before rolling it out to all of our feature developers. And we've had some other priorities, like we'll talk about in the next slide sort of too, why we haven't gotten to that yet. And then also coming up, probably the next either subversion or minor version or actual major version, we'll finish doing our nomenclature changes. So a lot of our stuff internally has begun swapping, but that is one of our sort of next way we'll have to lay the groundwork. So similar to isolating like the CDC replicas for sourcing, this will be something that we'll have to do internally before we move forward. So before I get into the questions, some of you may be wondering, well, what about the performance? You switched it over to 8.0. You haven't talked about this whole talk. So previously I mentioned our ORMs at Yelp. So we have it as our monolith cluster. Uses some legacy ORMs, and those legacy ORMs were written with, I believe, Easy Alchemy or Easy SQL, and then we wrote our own. When we upgraded 8.0, those queries or models took a significant hit. And so it took, I want to say, 2 or 3 years for us to get agreement and actual planning to get rid of those ORMs, and that's what we're actually doing this year. So I think we are down to already 30%, and we started in January. So we're hoping by the end of the year we can actually look at our performance of those queries and see an improvement rather than the multi-shared tenant cluster getting messed up by those older, more archaic query patterns that we've written, and older ORMs or self-written. But yeah, that is the at least preset question I had. So I'll open it up to the floor. And first off, I just want to thank everyone. Thank you again, Oracle and the community managers, for putting this all together.